Hi, this is a supplementary math lesson for Algebra 1, Lesson 85B and C in your textbooks. The slope and the intercept of a line in the general form of the equation of a line. Okay, so we have introduced that topic yesterday. The general form of the equation of a line is here, and most of you have sent back the email identifying the pieces parts of that. Okay, if you haven't done that lesson first, go back and do that lesson, the video, the email I sent out yesterday, and then come back to this lesson. Okay, and again, don't let this throw you. Okay, we use general form. It's just the general format we like to express a straight line in. And remember, this is applicable to a sloped line. That's what we went over yesterday. Okay, we are doing a sloped line lesson in Algebra 2 today. Okay, they're given a bunch of data points. They have to determine what is the slope of those data points when you connect them with a line. Okay, in advanced math, we've been dealing with the general form of the equations of circles and parabolas. Okay, it's just a format that mathematicians like to put that in. And okay, so they'll give us an expression like this, and they'll say, go ahead and graph this expression. And we say, we're going to use these pieces parts now to help us shortcut a way to graph this line. First, we have to get it in the right form. Okay, we have to get it y equals. Okay, so we get y alone on the one side. Let's send the x over to the other side and the 6 over to the other side. Let's divide out that 2. So we get y equals. Now, typically, we don't leave this term as x over 2. Okay, although algebraically there's nothing wrong with that. We like to split it like they have here to put the slope in front. So we're going to change that divided by 2 into 1/2 x minus 3. Okay, so we said, what was the pieces parts that ended up being this constant number at the end? It was called the intercept. Okay, we noticed if I set up my data points, and one of the ones I always picked was 0, x equals 0. When x equals 0, that term cancels out. What's left in the equation? Minus 3. Okay, so we know when x is 0, in other words, when x is at the origin is 0, y is minus 3. We plot it down there. Okay, we don't need to, that's the beauty of 0, we don't need to have a graph of data points to determine that. We can just use our hand, cover up the x term, because it's going to be eliminated when it's 0, and that number remaining is going to be where it crosses, where it intercepts the y-axis. That's why they call it the intercept. It is crossing, it is intercepting, it is intersecting the y-axis. This is our y-axis, x-axis, at minus 3. Okay, so that's easy to determine. We already have one point of our line then when we do that. So then the other thing is we use the slope, which is the number in front of x, to help us shortcut how to do the second point or additional points if we want to do that. Okay, now let's just look at what's going on with the slope. I'm just going to take that term of the line. I'm going to not put the, since we already figured out where the intercept was, let's just look at what's happening here, okay, with this. Okay, when I put a value in for x, let's say 1, what's happening to y? Y is 1/2 times 1, it's a half. Okay, if x is 10, what is y going to be? It's going to be half of that, 5. Okay, so the relationship is this. Y is always going to be return 1/2 the value of x. That's why we say it has a slope of 1/2. Okay. Let's define the slope as this. M is the slope. We're going to define what is a slope. A slope is a rise over the run. Okay. The rise, what do we mean by rise? That means the amount of change in the y direction. That is our rise. Okay, think of it as a roof. Okay, we express roofs in terms of slope. Okay, they'll say a 4 and 12 slope on a roof. That means the angle of the roof rises 4 units for every 12 units of horizontal run. Okay, it rises 4 units and it runs for 12 units. Okay, if that roof is steeper, say a 12 and 12, okay, it rises 12 units and runs for 12. If the roof is shallower, say a 2 and 12, it rises only 2 units per a run of 12. Okay, so that's just a visual, a tool to help you understand what's going on with rise and run. Okay, so I'm just going to put in parentheses, the rise is the change in the y. Okay, delta, the triangle is a symbol for change. It's just how much y changes divided by how much the x changes. Okay, what is that in this case? It's 1/2. Okay, so let's apply that from our point. Now, we read lines in the same way we read English, from left to right. So we always start to the very left and proceed to the right. Okay, and we apply the rise first. Okay, and let's do that. So it's saying it's going to rise 1 unit and then it's going to run 2 units. Now both of them are positive. We have no negatives in the equation. Okay, so right now that means we would rise 1 unit positive. Positive is the up direction. We would run 2 units positive. 1, 2, and that would be our next point. Okay, rose 1 unit, we ran 2 units to the right. If you want to do it again, you could do it again. You can apply it from this point. I'm going to rise 1 unit and run 2 more units. Okay, and then I can see those 3 are in a line, and I can go ahead and attach them. Okay. Now, we notice that slope has a positive value. It doesn't have a negative symbol in front of it. Okay. Let's see what would happen if that slope were negative. Minus 1/3 x, let's say. Okay, well, we start from our point, if this is our point of our line, and we'll use the same y-intercept, -3. Let's apply our slope from there. What do we apply? It has a negative symbol, okay? So we always apply the sign to the rise, to the numerator, okay? In this case, it's a -1. That means our rise is -1. We are dropping 1. And then going to the right 3. The run will always be to the right. It'll always be to the right, never to the left. Okay, we apply the negative to the rise, to the numerator. Okay, we never apply it to the denominator. Okay, so we drop 1 and we go over 1, 2, 3. Okay, we would drop 1 and go over 1, 2, 3. And we're going to connect our points. We notice when our slope is negative, when we read our line from left to right, it proceeds in a downward right direction. When it's positive, it proceeds in an upward right direction. Okay, we can use the right-hand rule for that, and this is how I do it. I go ahead and I face the origin of the board, and then I take my right hand. And what is the slope doing? If this is the x-axis, is the slope of the line going up or is it going down with my right hand? Well, this one is going up, so the slope is positive, a positive value. This line, the line is going down, okay, a negative value. So you can use that right hand rule to keep track. Is my slope positive or negative? okay? Lines with positive slope will always proceed upward and to the right. Lines with negative slope will always proceed downward and to the right, okay? So that's two ways we use that shortcut method to graph a line without even substituting data points in. Well, in effect, we substituted one in. We substituted 0 in, got -3 as the intercept. Got -3 as the intercept. Then we applied the slope. In this case, a positive 1/2, 1 unit of rise, 2 units of run. In this case, a minus slope. So we drop in our rise. It's a drop, a negative rise over a run of 3 units. Okay? So that's the first way that we're going to use this method to solve problems from here on out. And then the other one is, okay, they're going to give you a graph, okay, they're going to give you the graph of something. They're going to give you a line on a graph, and they're going to say, give me the equation of a line. And you'll be like, whoa, there's nothing there. There's not even any numbers on the graph. Well, we assume the tick marks are 1 unit apart, okay? So, well, we use the equation of our line, the general form of the equation of the line, okay? Okay, let's go ahead and bring it over here. You'll write it out, okay? Now, the first thing we notice, the line crosses the y-axis at which number? +1. Okay? What do we call that in the equation of the line? We call that the intercept. B is 1. We already have one part of our line. Okay? We have y equals mx plus 1. Okay? Now, what do we need? Okay? Now, we always keep the y and the x in it, so all we have to do now is determine what is the slope, the m. The slope is going to be the rise over the run. Okay? Now, to do that, I need to know 2 points on the line. Okay, I already determined what this point was. And I look at the line. Where does it cross another point that will help me determine the slope? And just like we did in roofs, okay, the slope of a roof, we notice one side of the roof forms a triangle. That will help us define what the slope is. If that slope of the roof is 4 and 12, the rise will be 4, the run will be 12. Okay, we're going to do a triangle on our line to determine the slope in the same way. Okay, well, I notice the line crosses exactly at this point here. What that does is it forms a triangle at this point. Okay, I have a triangle at this point. What are the rise and run of that triangle? I already said it went up 1. What does it go over here? 1, 2, 3 units. It runs 3 units. Okay, now again, I read my lines from left to right. So I start all the way over here at the left. What is my rise? My rise is 1. Okay, what is my run? My run is 3. I apply the rise first and then the run. Okay, it's a positive number, I notice. Okay, why? Okay, my rise is in the positive direction because I look at that one first. Let's confirm with the right-hand rule. If I look at the graph, looking at the origin, I put my right hand out. Which way does the line go? The line goes upward to the right. It's a positive slope. Okay, our slope then is positive. Okay, what is the equation of the line? I put that slope in there, 1/3 x, and my intercept stays the same. That is my equation of the line. I didn't have to come up with any data points. All I had to find was 2 points on the line where I could determine that triangle. Okay, I want to pick a point that's going to cross an intersection of lines pretty exactly. Okay, I don't want to pick a point on the line right here where it falls in between 2 points. Okay, I want to pick it where it's going to cross tick marks exactly like it did over there. Okay, so that will be the second way in which we use this method. Okay, they'll give us a line, and then we'll go ahead and determine that slope with that. Now, I've noticed something with this curriculum that will help you determine slopes. Okay, when they give you a graph on your book, they'll have it encased in a square, and the line will actually go off the edge of the square. And I've noticed most times in the problem sets, they will go off at the exact place at a tick mark. Okay, here at 1, 2, 3, and 1, 2, 3, 4, 5. So here the point would be 5 and 3, and over here it would be 1, 2, 3, 4, minus 5, minus 1. Okay, so what you can do in those cases is you can determine your triangle where it goes off of the edge of the graph, like this, that big triangle. And let me erase everything in the middle to highlight that. Okay, so that will help you determine what is going on with the slope. Okay, so use the points where the line goes off the edge of the graph, left and right, to determine your triangle at that point for determining the slope. So that will help you pick your points, because I've noticed generally where it goes off the graph is exactly at the crossing point of 2 points on the graph. So that will help you, I think, in your selection of those points. So I hope that helps. What are we doing? We're using that general equation of the line, knowing what the pieces parts did, to 1, if they give us the equation, we can graph the line without doing data sets now, data points. That will be helpful. It'll save a little work. And number 2, they will give us a line, and we can determine the equation from that with the proper selection of some points, determining where the intercept is, and then determining the slope from those properly picked points. So I hope that helps. This will take a little practice, and we're going to be practicing it pretty good again all next week. And going forward, this is a skill. This is something you need to understand, and how to do front ways, back ways, in your sleep, in the dark, okay, on a boat, with a goat, any which way you can think of it. You need to know how to do this skill. Like I said, we're doing it in Algebra 2. We continue to do it in advanced math. We've been doing this skill in physics even. So it's not a skill that goes away. It's something you need to understand and grasp, and especially for standardized testing. You really got to have this one down. So have a great weekend, and that's it for now. So long.